Each day I lose more than 2 hours on public transportation. Electric scooters are quite expensive for now. So I start making myself my own DIY homemade electric scooter, and in this video I will show you what you need and all the steps to build your own. Finally, we will test it, find the maximum speed and the total kilometers that you can make with full batteries. So let's get started. What's up, my friends? Welcome back! The first thing I need to do is to get myself a second-hand scooter in order to keep this project cheap. And here comes the first price explanation of the project. This homemade scooter could change its price depending on your weight. I'm a big guy, so I had to buy a big scooter that could handle my weight. Then I need a big motor, which will be expensive, and also I will need more battery life for the same amount of made kilometers. When I start making posts of this project on my Instagram account, a lot of you guys start commenting that there are cheaper components for this project. And of course, if you weigh 60 kilograms, you could use smaller motor and less battery, and also a smaller scooter. But that it's not my case, and that explains why I've used big parts. So, I've used this second-hand app to find myself a good scooter. The app is called Wallapop, and I'm not sure if it works worldwide. I found a bunch of good scooters nearby, and I've chosen this one for only 20 euros. It is a big adult scooter and it's very cheap. So I've got myself a scooter. Let's talk a bit about the other components that we need. I've bought all the parts from Banggood for a very nice price. I've searched for hours in order to find the best product and the best price. You've got all the links for each part in the description below if you want to make your own scooter. Okay, so we will definitely need a powerful motor that will drive the scooter. I went with the Racer Star 6368 brushless motor. Those numbers are the diameter and height of the motor. This is an amazing 480 watts power brushless motor. It is huge, here's a banana for scale. Only the shaft is 1 cm diameter, so imagine the size of the entire motor. As I said before, I need a powerful motor to drive my weight. And for powerful motor, we need a powerful controller. I went with the Racer Star 120 amps waterproof electronic speed controller. It can handle up to 6 LiPo cells and it could deliver up to 120 amperes of current. I'll leave all the extra information about each component in the description below, so if you need to program the ESC or check any of the datasheet values, please check the description links. Okay, the next thing that we need is battery. I went with two 4-cells 4500 mAh LiPo batteries, and I will probably add some more in the future to have more battery life. I'll connect these batteries in parallel to have 14.8 volts and a lot of battery capacity. As extra components for the control, we will need an Arduino. And then you could use a linear sliding potentiometer like this one, or use the 3D printed case that I've designed with a normal potentiometer to accelerate. Then you will need an elastic rubber band, wires, screws, bearings and metal parts. We will see all those parts in detail in a moment, and you will have a full part list below. Okay, let's start this project. The idea is that using the potentiometer, we will set the speed inside of the Arduino reading the analog input. This will apply a PWM signal to the ESC in order to control the motor. Somehow, we have to attach the motor to the back wheel. Add a case for all the electronics and the project will be done. Please, before you start soldering and mounting, look over the main schematic of the project. the Arduino code explained and all the extra information on my webpage. Once you do that, this should be very easy. Okay, I first want to center over the most difficult part of this project. That part is transferring the rotation of the motor to the wheel. I've planned two options. One, it's using a geared pulley and timing belts, and the other one, it's adding a direct pulley between the motor and the wheel. For this try, I went with the second option and I'll explain why. Adding geared pulleys to this scooter is quite difficult. First, you have to find the position of the motor around the wheel. Add one gear pulley to the wheel, which I think is the difficult part because probably you will have to attach the pulley to the wheel shaft or use a bigger geared pulley and drill some holes in the wheel body. Besides, there is not enough space between the wheel and the scooter body to add the pulley in my case. Then, you have to make sure that the timing belt is tensioned, so you should also add some kind of tensioning system. That's why I've chosen the second option. Okay, let me explain how this will go. Somehow, I'll manage to fit the motor behind the wheel using metal bars and screws. On the shaft, I will add a pulley that will get pressed against the silicone wheel. And that's it. I'm not sure how this will go, but hey, it's a DIY project, so I had to try this option. Okay, we have the main idea. Let's talk a bit about this pulley system. I first wanted an aluminum pulley, but that is very difficult to find or make in my case. It needs to have 1 cm shaft bore, curved perimeter that will perfectly fit on the wheel, and also extra holes for screws and bearings. Finding a commercial pulley like this one is very difficult, so I will probably make my own in the future. For this first version of the project, I've 3D designed and print one that will suit the requirements. Make sure you print it using more than 40% infill and 4 perimeters in order to have a strong part. Also, once the part is finished, you could also add some extra layers of double part epoxy to make it even stronger and also have a better contact between the wheel and the pulley. Okay, let's comment one crucial component of the pulley system. When you apply power to the motor, this will spin the wheel. Pretty straightforward, right? But when the potentiometer will be in its lowest position, meaning that you're not accelerating, no power will be applied from the ESC to the motor. But when you are riding, the scooter will keep moving forward. And now won't be the motor that will spin the wheel, but the wheel that will spin the motor. That means that the motor won't act like a motor anymore, but as a dynamo. We all know that spinning a motor will create a voltage at its output, as any dynamo will do, as we can see here on the oscilloscope. This voltage will be backwards to the voltage applied from the ESC. We don't want that, since it could damage the controller. Usually, ESCs have backward voltage protection, and there should even be ones that could charge back up the battery using backward voltage at the same time that the scooter will be braking. In this case, I want to make sure that I will minimize the backward voltage value. For that, we should use a clutch. A basic clutch system would separate the force between the shaft of the motor and the spinning wheel when not accelerating. There is not enough space for a basic clutch system in this case, so I went with this idea. This is a one-way bearing. As you can see, I can freely spin it on the shaft in one direction, but it will get tight when spinning in the opposite direction. And that's just great, and also very low cost. It means that I will have a strong connection between the motor and the wheel when accelerating, but there will be no friction when the motor stops, so the scooter could keep on moving without creating backward voltage or lose power. I also want to add the fact that designing the pulley wasn't easy. I've made a lot of print tests till getting the perfect one. Also, have in mind that a bigger pulley means higher top speed, but lower torque. I want to have more torque than high speed, so I went with a small pulley. In the description below you will find some example STL files that you could print. I've used my dear Creality CR10 3D printer, which by the way it's a very nice printer. I've used 4 perimeters, 45% infill and the 0.4mm nozzle. The bearing has a round shape, so I will have to glue it inside of the pulley in order to not spin freely. I've used a very strong double component epoxy. I'll put 2 of these bearings inside of the pulley and a normal 22mm bearing on the other side in order to have the same tension from both sides. This second bearing is optional. Okay, now that we have each part explained, let's build the motor support. I went out to my local Home Depot and bought some metal bars. These 90 degrees V-shaped metal bars should be the best choice. I've cut 2 equal bars. You have the dimensions of the metal bars in the description as well. You could add 1 of these bars on each side. On the left side will be the motor, and on the right side I will have a screw that will fit inside of the normal 22mm bearing. The second metal bar is optional, since the curved shape of the pulley won't able it to get out if it's well pressed against the wheel. Once I had that, I drilled the holes in the metal body of the scooter, so I could screw in place the metal bars. Make sure you will have wide holes on the metal bars, so you could later move the bars closer or further from the scooter body in order to perfectly adjust the pulley on the wheel. Now, fix in place the bars and measure where you need to drill the holes for the motor. Then, remove the metal bar and screw in place the brushless motor. In my case, using just 2 screws. Make sure that the bar won't touch the shaft of the motor. Also make sure that the one-way bearing is spinning in the correct direction and fit the pulley on the motor shaft. I first added a clip ring on the shaft to make sure that the pulley won't go further than that, and now I put back the pulley. In order to strong press the pulley against the wheel and ensure a good friction, here is what you have to do. Screw all the screws on the V-shaped bar, but don't get them tight. Put the pulley a little bit on top of the scooter wheel. Now you should keep these parts in this position and tie the screws. Also, you could use a small hammer and push the pulley against the wheel a bit before tensioning the screws. You should decide the amount of pressure. It can't be too tight, but it can't be too loose neither. The way you build this structure depends on you, the scooter shape that you use, and all the parts and tools that you have, and so on. You could also use some sort of hinge system with steel resorts like this one that will apply force downwards on the pulley. I will leave the links for other options and extra components in the description, so make sure you check that. How you build this part of this project might change in your case. As I said, the second bar on the other side is optional. Add that bar with a screw that will press the second bearing if needed. I will leave mine like this for now. Okay, so I've got my motor in place. Now using my hand, I test if the one-way bearing system works. And indeed, I can spin the motor in one way with no problems, but in the opposite direction it will apply force to the wheel. That's exactly what I want. Now let's prepare the other parts. What I want to do is to fit everything inside of a case that I will build and place it here in this area of the scooter. In this way I could still close the scooter without touching the parts. I will try to make this case water resistant, so only the 3 wires to the motor will get out of this case. I've 3D designed and printed these supports that will get screwed on the main rudder shaft of the scooter here. I can fit the 2 batteries on the bottom part support. Next, on the sides I've cut some plywood and wrap it with carbon fiber vinyl design. You have the sizes of these 4 plywood pieces in the description below. Inside I will fit the 2 batteries, the ESC, the Arduino and extra wires. I soldered the 5 volts, ground and signal wire to the potentiometer pins, and I placed the potentiometer inside of the 3D printed case. I screw the case in place on the rudder, and with a rubber band I make the throttle always go back to the initial position. I pass the wires downwards, and later I will solder the analog input of the Arduino A0 inside of the case that I'm building, and the throttle will be ready. Now try to use thick copper wires from the ESC to the motor, since there will be a huge amount of current passing through those wires. Also use a lot of heat shrinking tubes to insulate any connection. Before I fit everything inside of the case, I make a test using the Arduino Uno. First, I solder the 2 batteries in parallel and add a T-LiPo connector and also heat shrinking tubes for insulation. This speed controller has a 6.25 volts output in this case, so I'll connect that to the V-in pin of the Arduino, so now I have everything powered. The PWM signal will be digital pin 3. So also share ground and that pin with the electronic speed controller, and we are ready to go. Download the code from a link below and make sure you read all the comments in the code in order to understand it. The only thing that this code will do is to apply a PWM pulse to the ESC depending on the position of the potentiometer. Also, I add a small delay between the speed change, because if not, the motor will stop almost instantly, and that could damage the parts or even throw you out of the scooter. You should know that this electronic speed controller could perform both clockwise and counterclockwise rotations. With PWM pulses from 1500 to 1000 microseconds, it will spin in one direction. And with pulses from 1500 to 2000 microseconds to the opposite direction. That's why in the code I mapped the maximum PWM values from 1505 to 2000 in order to make sure that it will never spin backwards. If you use a different electronic speed controller, make sure you know the correct PWM range, which usually is from 1000 to 2000 microseconds. Okay, let's test if the code works. For this test I've used the Arduino Uno, but later I will use the Nano because it's much smaller. Upload the code to the Arduino. Connect the LiPo battery pack to the ESC, and that will power everything up because the ESC has a 6.25 BEC output connected to the Arduino. After the initial beep, I can increase the throttle. I move the potentiometer and there you go, the motor starts spinning. Perfect, everything works, but just one thing. The motor is spinning in the wrong direction. For that, just swap 2 of the motor wires, and there you go. Now everything works okay. It's time to mount everything inside of the case and finish this project. For that, I first place just the back and sides plywood parts on the plastic support and glue those together. Next, I take them out and apply the carbon fiber vinyl. I place back the plywood parts and the main base of the case is ready. I fit the batteries in place and now I start working on the front part of the case. I have to place the ESC on the front plywood sheet using 3mm screws and one thin metal sheet like this one. The electronic speed controller must be placed on the top part so it won't hit the 2 batteries, and also make some holes from the front fan. The ESC has an on and off button, so I've made a hole where I will place this 3D printed push button. I glue that in place on the back side of the plywood. I add the carbon fiber vinyl and screw the ESC in place. Now I can turn it on using the 3D printed button. Okay, now I make a side hole for all the wires. The 3 wires from the motor and also the wires from the potentiometer. I make the connections for the Arduino Nano, cut the ESC wires and solder the new longer wires. I insulate everything using shrinking tubes. Also, the electronic speed controller will only start if this small push button is pressed. That's kind of annoying. That's why I have 3D printed the plastic button, so now I can start the controller without opening the case. Okay, I connect the LiPo T connector and close the front part of the case. I screw the entire case on the main rudder axis of the scooter. Now all I have to do is to pass the wires to the best places till I reach the motor. I use zip ties and shrink tubes once again. So, the scooter is ready for the first test. I've tried to make this project water resistant as much as possible, but I kind of fail on that point. In a future part, I will redesign the case and the rain protection 3D parts and make a new update video, so stay tuned for that. But for now, let's test the scooter. I press the button and start the ESC. Long press the same button and that will turn off the ESC. Once it is on, move the throttle potentiometer and there you go. Let's go outside. I first charge the batteries at their full capacity. The first pulley failed in around half hour. That's due to the fact that the shaft of the motor is only perfectly round at the base. In the upper part of the shaft I have this cut. At small forces the bearing could spin okay, but when I was riding the bearing failed and broke everything. So I redesigned a new pulley with only one bearing that will sit on the perfectly round part of the shaft. I've printed this one with 4 perimeters, 45% infill and also add 2 layers of epoxy. To increase the glue effect, I've carved some lines on the bearing and then glue it in place. Install the new pulley and let's test the scooter once again. Okay, using a mobile app I've measured my top speed and the full distance that I can make with fully charged batteries. I've reset the app and start riding. I've reached a top speed of 33 km per hour, which is quite nice, but as a mean I was riding at 20 km per hour all the time, which is quite good for a first prototype. I've also made a total of 17 km and there was still battery for more, but I started to feel the voltage drop. Okay guys, so is this a perfect homemade scooter? Well, of course not. But it's a perfect prototype to learn and make the second version even better. So let's talk about the bad things of this project. In the future I will try to solve all those problems. First of all, the pulley. I mean, plastic pulley, what was in my mind? The pulley is getting quite hot due to friction, so if I make like 6 or 7 kilometers each day, it will definitely won't last even a month. So, a metal pulley should be my first improvement. I'm planning to get myself a lathe machine and carve my own design pulley out of aluminum. Now I'm also sure that the motor is powerful enough to drive my weight, so I could even increase the size of the pulley for more speed. I couldn't know that before, but now with the plastic prototype I do, so when I will make the metal pulley it will be the best design. Also, the system doesn't have a low battery buzzer, but the ESC does have a battery control that will turn the ESC off at low battery. Next, to charge the batteries, you have to always take them out. The next new case will have some water resistant connectors on the outside of the case, so you could charge the batteries without opening it. Also, I will try to improve the potentiometer system and maybe give a paint job to the entire scooter. But for now, I have to say that this scooter is awesome. The idea that it's homemade makes it even cooler and also make me proud. And the price is quite lower than the commercial one. It is very powerful and you could feel a really nice throttle when you're on it. Also, have in mind that I weigh more than 100 kilograms and that will reduce the maximum distance that you can make and also the top speed. If you weigh less, you could only use smaller and cheaper components. You have all the prices and the component list below, so check those out. Stay tuned for the next upgrade of this project. I am very happy with the results and I'm amazed of the power of this scooter. I will try more pulley sizes and see the effects. The scooter looks quite cool for now. Guys, if you like my projects and consider helping my workshop, check my Patreon page. I would really appreciate that. I hope that you enjoyed this first version of the project. If so, don't forget to click the like button like crazy and share the video with your friends. If you have any question about this video or any other, just leave it in the comment section below or my Q&A page. Also, don't forget to subscribe and watch all of my other great tutorials. If you consider helping my project, check my Patreon page as well. Thanks again and see you later, guys.